Hi, good morning dear children. We are going to learn the next topic, different types of energy. Firstly, we are going to study what is potential energy. In the lower classes, you already studied the term potential energy. Simply, we can say that if a body is at rest, that means a body is not moving or body is not changing its position, then that body possesses the potential energy. Potential energy means it is the energy possessed by a body due to its position of rest, shape or its size. Okay? For your knowledge, simply you can understand that if a body is at rest, then it possesses potential energy. Commonly, we are representing potential energy with a short form PE, capital letter P and capital letter E. Potential energy means that is equal to mgh, where m means mass and g means acceleration due to gravity. Okay, acceleration due to gravity. And h means that is the height. How above the ground level? Suppose it is the ground level. We are placed a body on the top of a tower or the first floor of our house, then it is the ground level, then it is the height. And here suppose this is the body and then its mass is m, then potential energy is equal to mgh. The value of g we are commonly taken as 9.8 meter per second square or meter s inverse square. Okay. Here g is equal to 9.8 meter second inverse square. Then potential energy means simply you can understand it is the energy possessed by a body due to its position of rest. That means body is not moving, body is not changing its position. Okay, can you follow me? Potential energy. Potential energy means it is the energy possessed by a body due to its position of rest. That is the equation potential energy is equal to mgh. Okay. Next we are going to study the next form of energy, that is kinetic energy. It is just opposite of the potential energy. In the case of potential energy, we told that is due to the position of rest. Here, the energy possessed by a body due to the position or due to its motion. Suppose a body is moving, suppose a body is changing its position, then we can say that that particular body possesses kinetic energy. Can you follow me? And commonly the representation letter for kinetic energy is capital letter K. In some text that is written as Ke, kinetic energy. The equation is half mv square. There the m means mass and v means velocity. Okay, can you follow me? And you have to remember, that is, we got potential energy. Therefore, potential energy, that the equation is mgh. And in both cases, that means the unit for potential energy and the kinetic energy is joule. Or we can write it in this way, capital letter J. Okay? Can you follow me? Okay? I hope now you got the idea about potential energy and kinetic energy. Okay? Then we are going to learn one important topic, that is the derivation for kinetic energy. Okay? We are going to derive or find an equation for kinetic energy. K is equal to half mv square. Consider a body of mass m moving with a velocity v. A body of mass m moving with a velocity v, and we are applying a force F to stop that body. That means at last the body comes to rest. Okay? A body of mass m moving with a velocity v, we are applying force to stop that body. Then the body comes to rest. Okay? Is it clear? Then actually the body is moving with a uniform acceleration before we are applying the force to stop that. Anyway, not go to in detail. Here you have to remember, a body of mass m is moving with a velocity v, and we are applying a force on that body to stop that. Then the body comes to rest. Simply we can consider one example. A bus is moving with a uniform acceleration. We know the symbol of acceleration, that is a. That means the initial velocity of the body is v and the final velocity becomes 0 because body comes to rest. And coming back to my example, a bus is moving, a driver applying brakes. Then the bus comes to rest. Then the bus comes to rest. Can you follow me? Then here we know force is equal to mass into acceleration. Then F is equal to ma. Can you follow me? Kinetic energy means we know one equation for work, that is force into displacement. And in the previous class I told you we know one equation W is equal to F as force into displacement. And I told you work and energy are numerically equal. Work and energy are numerically equal. The value of work and value of energy are numerically equal. So I can write energy also force into displacement, that I told in the last class. Then here we can consider kinetic energy is also Fs. That is, I am writing kinetic energy K is equal to Fs. F means that is the retarding force into displacement. Can you follow me? The retarding force means we are applying force to stop that body. That means we are doing a negative acceleration, or the body obtaining a negative acceleration or retardation or deceleration. This term is you already studied in the 8th and the 9th standard. The velocity of a body gradually decreases. Then that body has the negative acceleration or deceleration or retardation. Three terms are the same idea. Here kinetic energy means that is retarding force into displacement. That I wrote kinetic energy is equal to F first. Now we know the value of F, ma, no problem, but we have to find out the value of S. That is the task to derive this equation. Listen very carefully. Kinetic energy is equal to force into displacement. We know the value of force, that is equal to ma. S is the displacement. Okay? Then we have to find out the value for S. Okay? Here I am doing just this. The 9th standard we studied one equation, v square minus u square is equal to 2as. Third equation of motion, v square minus u square is equal to 2as. Okay. Here v means the final velocity, u means the initial velocity. Here according to our condition, initial velocity is equal to v and the final velocity is equal to 0 because the body comes to rest, and the acceleration is negative a because retardation or deceleration or negative acceleration. Okay, so this is the equation, v square minus u square is equal to 2as. We have the values. Initial velocity, final velocity, that is equal to 0 square minus initial velocity u, that is the here v is equal to 2 into, in the place of a, that is negative a into s. Negative v square is equal to negative 2as. Then v square is equal to 2as. We need the value of s, that is equal to v square by 2a. Now we got the value for displacement, s is equal to v square by 2a. Can you follow me? We know the equation, v square minus u square is equal to 2as. V means the final velocity, that is 0 because the body comes to rest. Therefore 0 square minus u, that is the initial velocity. The question starts with the body moving with an initial velocity of v. So v square is equal to 2 into acceleration, here that is retardation, so negative a into displacement s. Negative v square is equal to negative 2as. Negative sign is cancelled from both sides. V square is equal to 2as. Therefore s is equal to v square by 2a. Can you follow me? Then we got the value of force ma, and for the s, substitute here k is equal to fs, that's equal to ma into, in the place of s, v square by 2a. A can cancel, k is equal to mv square by 2. That we can write k is equal to half mv square. Okay, this is very important derivation that you have to study well. I know it is very difficult to catch or difficult to understand this type of derivations in an online class. Dear students, pray to God we can meet in the classroom as soon as possible. Then we can study these derivations in the classroom also. Please don't be panic. Study well. Pray to God to avoid all these COVID scenario.